Okay. So honors pre-calc. We are going to take some notes today on section 5.5, day 1. I would have your unit circle sheet out so that you can follow along with the formulas that we're going to be looking at. We're going to be using the double angle formulas today. On your formula sheet, though, I can't remember if for tangent 2x, if it only lists this first equation. If so, I would add in this second option. So I would write that in real quick. So these formulas are what you can use now if you see a problem where you've got a 2 in front of the x for either sine, cosine, or tangent. So you can replace a sine 2x with a 2 sine x cosine x if you want. For cosine 2x, you have these 3 different options, and you can do one or the other. You can pick one. You do not need to do all 3 of them. And just depending on the problem, if the problem is involving only sines, you would probably want to use this bottom one. If the problem is involving cosines, you might want to use the middle one. Most times it doesn't matter, but sometimes you might want to be clever in which one you pick. Same thing goes with tangent 2x. You can use either this formula or this formula. So we'll just do some examples. You can see which formula might be the easier one to go with. Okay, first example. We're just kind of going to go through the mechanics of how to use the formulas. So this example is telling us that our angle should be between 3 pi over 2 and 2 pi. So they're giving us this hint that we should be in the 4th quadrant because that is between 3 pi over 2 and 2 pi. So draw your triangle in the 4th quadrant, and then we can label cosine is adjacent over hypotenuse. So I know that my adjacent side is 5, my hypotenuse is 13. Now we can do Pythagorean theorem to find the remaining side. 5 squared plus b squared equals 13 squared. 25 would equal b squared. Oops, not equal. Let me go back. 25 plus b squared would equal 169. So 169 minus 25, you get 144. Remember, when you take a square root, it could be a positive or a negative. So b is going to equal positive or negative 12. Which one should it be? Well, since this side is pointing down, it should be a negative 12. Okay, so sine of 2 theta, we can use the formula 2 sine theta cosine theta. And then we're going to plug in what we know. Sine of theta is opposite over hypotenuse. So that would be negative 12 over 13. Cosine of theta is adjacent over hypotenuse, so 5 over 13. Now we're to the point where we have all numbers, so we can multiply, and this 2 can be written as 2 over 1. So multiply straight across the top, you get negative 120, and multiply straight across the bottom, you get 169. For 2 cosine theta, we've got 3 different formulas we can choose from. It does not matter which one you choose. They will all get you the same answer. So I just feel like choosing the 2 cosine squared theta minus 1 formula. So that's what I'm going to go with. All right, cosine of theta is adjacent over hypotenuse, so it'll be 5 over 13, but we wanted cosine squared, so it'll be 5 over 13 squared minus 1. You could type all that in your calculator. and you'll get negative 119 over 169. For tangent of 2 theta, I've got two formulas I can choose from. I'm going to choose the bottom formula of sine 2 theta over cosine 2 theta because we've already found those. Sine of 2 theta is what we found at the top. That was negative 120 over 169. And then cosine of 2 theta we already found was negative 119 over 169. You could put those in your calculator and it'll simplify to 120 over 119. So that's just using the formulas. Pay attention to clues like this for what quadrant you should be in, so you make sure if a side is pointing down that it should be a negative. The next problem we're going to do is a solving problem. Okay, and we've done problems similar to this in the past. In the past, when you've seen a 2 right there, that has meant to go around the unit circle twice. But the issue with this problem is we've got cosines and sines. So it would help if we could get them all to be the same kind of trig function. But we can always use any identities. So what we might want to consider is replacing this sine 2x with the new identity that we're learning about. So we could replace it with a 2 sine x cosine x. And now I know that that does not make us have one trig function. We still have sines and cosines, but this term has a 2 cosine x, and this term also has a 2 cosine x. So we can factor out a 2 cosine x, and we would be left with 1 plus sine x when you factor out a 2 cosine x. And now that we've factored, we can set each factor equal to 0 and solve. Okay, so over here, if we divide by 2, 0 divided by 2 is still 0. To get the x alone, we would do the inverse cosine of 0. So look on your unit circle sheet. Where do you get a 0 for cosine? That happens both at pi over 2 and at 3 pi over 2. Over here, I can subtract the 1, so we will have sine x equals negative 1. To get the x alone, we'll do the inverse sine of negative 1. Look on your unit circle sheet where you get a negative 1 for sine. That happens at 3 pi over 2. So for our final answer, you see how we've got a repeating solution? You can just say pi over 2 and 3 pi over 2. We don't have to list the 3 pi over 2 a second time. So that can be our final answer right there. So if you see sine 2x or cosine 2x or tangent 2x, you can replace it with these new formulas we have. That might be a strategy to try. Okay, and then our last examples. All we're supposed to do here is just rewrite each of the following. So that's kind of another way of saying simplify, sort of. But rewrite basically means use the new identities. They're hiding in these problems. You kind of have to find them. So with A, for example, 4 cosine squared x minus 2. that has two terms. Both of those terms have something in common that you could factor out. We could factor out a 2, and then we would be left with 2 cosine squared x minus 1. And then you might recognize that the 2 cosine squared x minus 1 is one of our new identities, and that is the same thing as cosine 2x. So we've rewritten it 2 times cosine 2x. For B, looking at that, it's there. First of all, there's nothing common that we can factor out. I see 4 sine x cosine x, and one of the new identities is 2 sine x cosine x. That would equal sine of 2x. Now, we have something close. We have 4 sine x cosine x. I could be clever though, and I could write 4 as 2 times 2, and then I would have that sine x cosine x. And don't forget the plus 1 at the end. So all I did was write 4 as 2 times 2. And now we can say, oh, there's that identity right here, 2 sine x cosine x. That is the same thing as sine 2x. And then I would still have this 2 out in front. That 2 right there would still be out in front, and I would still have the plus 1. But it was just that this 2 sine x cosine x was kind of hidden in there. Okay, so that is in a nutshell what I want to cover for 5.5 day 1. All right, so you should be able to work on the homework in the book. Have a good day.